on the Utilities tab, there's a new tool to add a panel cutout. That is a small shape cut out from the edge of a panel. Panel cutouts are useful because they let us make a fairly simple meshing and paneling of a shape without having to worry about odd cutouts that are needed at the bottom of the panels, and then the panel cutouts can be added in later. The panel cutouts can be used for places where stanchions, pipes, frame members or ropeways go through at the bottom edge typically of a mesh representing a fabric surface. There are a couple of restrictions on using this tool. The first is that once the panel cutouts have been added, it is difficult then to get the Seam Allowance program to work, because the panel cutout can be an arbitrary shape, and so it's difficult to get the Seam Allowance to work with that, and so we typically always put a Seam Allowance on first. Let's just go ahead and add a Seam Allowance onto this panel. I'll make a copy of the old panel in the seam, delete the old. So here we have the panel with the Seam Allowance in it. And the second restriction is that the shape that we want the cutout to be is defined by a polyline. So if I just draw a polyline and say that we want to cut out just here, for instance, we would select that, the panel and the cutout, and run the tool to create a panel cutout. Delete the old, and here you can see how the cutout has been added to the cut line of the panel, and also the detail information on the inside has been trimmed back. In many situations you might want to produce a much nicer looking cutout than this. The cutout might be, for instance, defined by an arc, and I'll draw one in just here. So here we have an arc defining a cutout shape. Of course we know that the program won't use an arc, it uses a 3D poly, so what we have to do is create a 3D polyline which is based on an existing curve. So we convert the curve to a polyline. We have a whole load of settings up here which basically controls the number of points on the polyline. We just accept that, and then once we have that, we can then go ahead and trim back to that cut. Now often the position of the cutout needs to be determined from information that has been machine measured, and we would typically have that, get rid of that mesh, in the original frame measurement as a couple of points, and these are Rhino points, just ordinary 3D points. If your measuring equipment doesn't produce points, or can't be set to produce points for these locations, you might have to have a polyline drawn across there, and you might have to put a point on the end of the polyline to get to that. Once we have those points of course in the paneling, so I'll just go ahead and panel that. Are carried across into the panel as detail marks, little crosses, and whatever shape cutout you wanted to make can then be based, I'll just do this very roughly, can then just be based on those crosses, and of course the panel cutout created on that. You may have a situation where the entire cutout shape needs to be defined by the measuring equipment, and that can be coped with by having a series of points from the measuring equipment defining the shape of the cutout. Normally if we panelled this, those points of course would just all become individual little crosses in the panel. However, if we colour the points a significant colour, that is something like red, yellow, green, blue, etc., that instructs MPanel to join the points of the same colour together into a detail poly in the panel. So if I go ahead and select this, panel that, when I bring the panel down here, you will see that there is a detail poly in here. I would of course go through the normal seam allowance process and so on. And if I now run the tool to produce a panel cutout, but there is no detail, there is no panel cutout polyline provided, then the tool will automatically look inside the panel to try and find any detail polys like this which could be used as a cutout. So in this case, and of course I should have done the seam allowance first, but I'll just go ahead and do this. If I do the panel cutout with no cutout polyline provided, delete the old, the detail poly which was inside is used instead, and so we can now get a cutout which is exactly the same shape as the machine measured data.